Okay, in this problem, we're going to be writing and solving a system of two linear equations given a table of values. The first problem, a party rental company has chairs and tables to rent. There were two customers who rented both chairs and tables last week. The table shows the number of chairs, the number of tables, total cost in dollars for those two customers. So we've got the first customer last week that rented 12 chairs, two tables, and it cost $43. The second customer rented 3 chairs, 5 tables, and it cost $40. Okay, so what we're looking for is how much do the chairs and the tables cost? Okay, so if we set that up, the first equation would be 12x. In fact, before I do that, let's write x is equal to chairs and y is equal to tables. Okay, you could do C and T if you want. It doesn't matter. However you feel comfortable labeling them. Okay, so 12x, so 12 chairs, plus 2 tables, 2y, is equal to 43. Okay, and then the second one would be 3 chairs, so 3x, plus 5 tables, so 5y, is equal to 40. Okay, so we need to figure out what x and y are. We can use substitution or elimination, whichever one we choose. So I'm going to choose elimination. I'm going to try to get rid of the x's. So I will multiply the bottom one by -4. The reason I multiply by -4 is because when I multiply it times this, it'll turn into a -12x. And when we add straight down, it'll make that x term cancel. Okay, so top one remains the same. We're not multiplying it by anything. The bottom one becomes -12x minus 20y equals -160. When we add these down, the x's go away and you get -18y is equal to -117. Divide the -18 on both sides. Negative divided by negative is a positive, and you get y is equal to 6.5. Okay, so that gets us the price for tables. Excuse me. Okay, so now we need to figure out the price for chairs. So we just plug the 6.5 into either one of these equations and solve. Let's just use the top one. So 12x plus 2 times 6.5 equals 43. So 12x plus 13 equals 43. Subtract the 13 over, so you get 12x equals 30. And when you divide 12 on both sides, you get x is equal to 2.5. Okay, so the chairs were $2.50, whereas the tables were $6.50. Okay, let's do this one. So Rachel, the trainer, offers two solo workout plans, Plan A and Plan B. Each client does either one or the other, not both. Rachel trained on Monday and Tuesday. Table below shows the number of Plan A and Plan B clients Rachel trained each day and the total time that she trained. Okay, so we're going to set up these equations based on the day. Okay, so we'll say, oh, we can keep it as A and B this time. Okay, so 9A plus 7B is equal to 12. Okay, so that's the first equation. And the second equation will be the Tuesday one. So 3A plus 5B equals 6. Okay, so we're trying to figure out how long are each one of these workouts such that when she does 9 of the A, 7 of the B, she gets 12 hours. And how long is it such that when she does 3 of the A and 5 of the B, you get 6 hours. Okay, so that's the equations that we're setting up. Again, we're going to do elimination this time. It looks like the A is easy to get rid of, so I'll multiply this by a -3 so that when I multiply and add, the A term goes away. So top doesn't change, 9A plus 7B equals 12. Bottom one becomes -9A minus 15B equals -18. Add those down, your A's cancel, and you get -8B equals -6. If you divide the -8 on both sides and reduce, you get B is equal to 0.75, or 3/4 of an hour. Okay, so that would be, if you did 3/4 of an hour, that would be 45 minutes. Okay, so let's look at this, figure out what the A is. So we plug the B in here. to either one. Let's do the top one. So 9a plus 7 times 0.75 equals 12. Okay, and 7 times 0.75 is 5.25, so you get 9a plus 5.25 equals 12. And when you subtract the 5.25 from both sides, oops, 5.25, not 5.27, you get 6.75. So 9a is equal to 6.75. And if you divide both sides by 9, you'll get a is equal to 0.75 as well. Okay, so 0.75 of an hour for both workouts. So both workouts are 45 minutes if they wanted you to put it in terms of minutes.